Good evening, class 9, unit light, part, last part. Today, draw. Question number 1. Draw neat diagrams to show refraction of light through glass slab and dispersion of light through a glass prism. ग्लास स्ल्याबबाट रिफ्र्याक्सन देखाउने, ग्लास प्रिजमबाट चाहिँ डिस्पर्सन देखाउने. अल्सो राइट वान डिफरेन्स बिट्विन देम. देम मिन्स ग्लास स्ल्याब एन्ड glass prism. First of all, I'd like to write one difference. First of all, diagram. Then you can easily write down one difference. The difference is, first of all, let me write down. Draw a glass slab. This is a glass slab, rectangular in shape, perpendicular, incident ray, straight, bent towards the normal or perpendicular, straight but bent away from the normal. E R R I C. E O N P Q R S. PQRS is a glass layer. OB is a refracted ray. C emergent ray. This is lateral displacement. The index is already written. PQRS is a glass layer. Here, refraction of light to a glass layer. Refraction of light through a glass layer. Here we can't see the 7 colors. Here is the refraction of light through a glass layer. See, incident ray, refracted ray, emergent ray. Normal, angle of incidence, angle of refraction, angle of emergence. D, lateral displacement. PQRS, glass layer. Now, glass prism. Dispersion of light through a glass prism. See, first of all, a white ray of light, incident ray. Then instead of going straight, the light is bent. The deviation, first deviation angle is this. Then instead of going straight, it is bent away from the normal. 1, 2, 3, 4, 5, 6, 7. B I B G Y O R. B I B G Y O R. Give your color. This is dispersion of light through a glass prism. Give your, what is this? Dispersion of light through a glass prism. What is the main difference between them? Here the refraction occurs in the opposite directions, but here refraction occurs in the same direction. One difference is, here inside the glass slab, the white light is split into 7 colors, but the 7 colors recombine to form a white light. White light means a 7 color break, again 7 colors recombine to form white light. Here white light is split into 7 colors. B I B G Y O R, your color. What is one difference? One difference is, here in a glass slab, refraction occurs in the opposite directions and the seven colors recombine after refraction and we can't see the seven colors. But here in a glass prism dispersion occurs and we can see the seven colors. We cannot see the seven colors, we can see the seven colors. This is a glass slab, this is a glass prism. That is the main difference between glass slab and glass prism. Refraction occurs in the opposite directions and we cannot see seven colors. Refraction occurs in the same direction, so we can see the seven colors VIBGYOR. Full form: violet, indigo, blue, green, yellow, orange and red. Violet is deviated most, red is deviated least. And below violet, ultraviolet ray. Below the violet ray. And above red, we see infrared rays. See, invisible, ultraviolet ray, infrared rays. Invisible, violet, indigo, blue, green, yellow, orange and red are visible light. Visible and invisible. Question number 1. Main difference between glass slab and glass prism. See, glass slab is rectangular in shape, but the prism is triangular in shape. Triangular shape and rectangular shape. It has 3 rectangles and 2 triangles. That is the main difference between glass slab and glass prism. Before solving numericals, I have to write down some formulae. Question number 2, numericals. Solve the numerical. But before solving, you should know some numericals. Before solving, I like to 1 kilohertz equal 10 to the power 3 hertz. 1 megahertz 10 to the power 6 hertz or 10 to the power 3 kilowatt. One thing. Another, let V for light speed or say velocity. This one, wavelength. And in the sound chapter, you will learn more. F for frequency. F for frequency. There are others over. Main formula P lambda. Another is mu, refractive index. So let me write down the formula. First of all, B equal lambda f. Since B equal lambda f, we can easily write lambda equal B by f and f equal B by lambda. Derived formula. This is the main formula. V, velocity equal wavelength into frequency. So wavelength equal velocity by frequency, and frequency equal velocity by wavelength. The SI unit, velocity meter per second, wavelength meter, and frequency hertz, Hz hertz. One formula. You can derive other formula as well. And another related to refractive index. First formula is, see, real depth x upon apparent depth y. One formula of refractive index is real depth upon apparent depth. One formula. Another formula, velocity of light in air or vacuum. Say short form VA upon velocity of light in the medium. Say VM, velocity of light in the air or vacuum to velocity of light in the medium, like glass medium, water medium, diamond medium, etc. Another mu has another formula, refractive index, sin I upon sin R. When light passes from rarer to denser medium, y as angle I is more than R. R भन्दा I ठुलो हुन्छ. See, from rarer medium to denser medium, angle I is more, so sin I by sin R. Another is 1 sin R upon sin I from denser to a rarer medium. When light passes from denser to a rarer medium, R is more than I, or I is less than R. Meaning same, angle of refraction is more than the angle of incidence when light passes from denser to a rarer medium. I have already said the technique. You have to know that if light passes from denser to rarer medium, it is bent away, and rarer to denser medium towards. If you see the light is passing from, light is bent away from the normal, you should know that light is traveling from denser to rarer medium. If you see the diagram, that the refracted ray is bent away from the normal, denser to rarer. If the refracted ray is bent towards the normal, you should know that light is passing from rarer to denser medium. नेपाली away, टाढा गइरहेको छ, डेन्सरबाट रेयरतिर गएको छ भने लाइट away बेन्ड हुन्छ. नर्मलबाट टाढा गएको छ भने डेन्सरदेखि रेयर गएको बुझ्नुपर्छ. त्यस्तो बेलामा डेन्सरबाट रेयरतिर जाँदा R is more than I हुन्छ. सी, R is more than I. when light towards नर्मलतिर नजिक आएको छ भने हामीले बुझ्नुपर्छ रेयर टु डेन्सरतिर त्यो लाइट गइरहेको छ, towards bend भएको छ भने. So this technique is very important before solving the problem. Kilo means 1000, mega means 10 to the power 6, 10 lakh. V, speed of light, velocity of light. Lambda, wavelength. F, frequency. Mu, refractive index. Formula V equal lambda F. Lambda is V by F. F equal V by lambda. Refractive index, real depth by apparent depth, x upon y. Or refractive index, velocity of light in the air or vacuum to the velocity of light in the medium, VA by VM. Mu, sin I by sin R from rarer to denser medium. mu sin r by sin I from denser to a rarer medium. You have to know where is the light going, denser to rarer or rarer to denser. Let me solve some simple question first of all. Question number 2. See, question number 2. Now let me write one question. Question number A. Numerical question number A. Find the refractive index of glass if the light velocity is 2 into 10 to the power 8 meter per second in glass and 3 into 10 to the power 8 meter per second in vacuum. Now how to solve the problem? See, the given question is find the refractive index of glass if the light velocity, means velocity of light, is 2 into 10 to the power 8 meter per second in glass and 3 into 10 to the power 8 meter per second in vacuum. Then how to find the velocity? Solution is this. See, this one is velocity of light in glass. Velocity of light in glass, say Vm. Here M doesn't mean glass, not VG. Here M for medium, any medium like glass medium is 2 into 10 to the power 8 meter. It is given velocity of light in vacuum or say air, Va equal 3 into 10 to the power 8 meter per second. Given, velocity given. What is the refractive index? Refractive index mu equal what? In higher classes like class 11, you have to read this A mu G. A mu G. Refractive index mu equal what? Now we know what formula is used? Real depth by apparent depth? No. Sin I by sin R? No. Because angles are not given. Only velocity is given. So refractive index equal Va by Vm. Velocity of light in vacuum upon velocity of light in the medium. 3 into 10 to the power 8 meter per second. 2 into 10 to the power 8 meter per second. Cancel 1.5. So refractive index of glass is 1.5. Answer. Now I am going to write down some other numericals as well. Other numericals are as follows. See, one B number numerical. Frequency given, velocity given, find the wavelength. See, let me write down the question. Find the wavelength of any light, say red light, white light, find the wavelength of a wave traveling at 3 into 10 to the power 8 meter per second if its frequency is 104 megahertz. How to solve the problem? See, before solving, you have to know SI system or units. SI system. See, you need a calculator. See, what is given? Wavelength is given, wavelength to find, frequency is given, and speed is also given. Solution: speed 3 into 10 to the power 8 meter per second, and frequency f equal 104 megahertz, equal 104 into 10 to the power 6 hertz, because 1 megahertz equal 10 to the power 6 hertz. Megahertz to kilohertz, kilohertz to hertz. And what is to find? Wavelength. Wavelength lambda equal what? We know lambda equal v by f, velocity by frequency. Derived formula. Velocity value 3 into 10 to the power 8. Frequency 104 into 10 to the power 6 hertz. Then what you should do? Either you can quote it like this, 3 by 104 into 10 to the power 8 minus 6. You can quote it. This is 300. 300 by 104 meter. See, 300 by 104. You can write 3 into 10 to the power 8 divide by 10 104 and divide by 10 to the power 6 without quoting or by quoting. See, let me do 3. You write 3 into 100, that is 300, equal 300, divide by 104, 2.88, that is 2.88 meter nearly. So wavelength lambda equal 2.88 meter nearly. See, megahertz, 104 megahertz, 3 into 10 to the power 8. Velocity by frequency. Velocity is 3 into 10 to the power 8, and frequency 104 into 10 to the power 6. 300 by 104, 2.88 meter nearly. So the wavelength is 2.88 meter nearly. Question number B. Question number C. Question number C. First, let me write down the question, draw the figure, and from the figure you have to find out what? You have to find out C number, find mu in the following diagram. The diagram is this. See, from this diagram, what you understand? You diagram what ke bujhisa? See, the ray is bent away from the normal. The ray is, this is the actual path. The actual path is straight, but the ray is not straight, but it is bent away from the normal. What do you mean by this? The ray is passing from denser medium to a rarer medium. See, dr away and rd towards. Denser to rarer, away, rarer to denser, towards. this light is bent away from the normal. Since the light is bent away from the normal, you should know that the ray is passing from a denser medium to a rarer medium. What is the angle of incidence? The angle made by the normal with the incident ray. This is the angle of incidence, not this one. This one is not the angle of incidence. The angle of incidence is this one. This is not the angle of refraction. This is the angle of refraction. So, from the diagram, see the ray is bent away from the normal. It is denser, it is rarer medium. So, what is the value of angle of I? Here, symbols, same meaning, usual meanings. I for angle of incidence, that is 90 degree minus 50 degree. 40 degree is the angle of incidence. And what is the angle of refraction? This 90 degree minus 30, complementary angle. 90 degree minus 36 degree. 4 what? 54 degree. So angle of incidence equal 90 minus 50, 40 degree. Angle of refraction is 90 minus 36, 54 degree. Refractive index mu equal what? The usual meanings. We know refractive index equal sin R by sin I, because the ray is passing from denser to rarer medium. Since the ray is passing from denser to a rarer medium, you have to write down sin R by sin I. Or you can also write 1 by mu equals sin I by sin R. Why? Because the ray is passing from denser to rarer medium. Now, sin R, angle of refraction is 54 degree. Sin I is 40 degree. First of all, you have to write down the value. If the calculator is in degree or not, first of all, you have to find D. Then check this way, sin 30 degree. See, is it in the degree? No, the value is not. See, the value is 0.98 or something. It is not in degree. So, again check sin 30 degree. Is it in degree? No, it is in radian. It is also wrong. See, now check sin 30 degree. Now, if sin 30 degree is 0.5, it is half, it is in degree. अर्थात sin 30 गरेर 0.5 आयो भने मात्रै यो डिग्रीमा मान्ने भयो. डिग्रीमा चेक, डिग्री चेक. Now, degree check. Sin 30 equal 0.5 or half. आयो भने यो डिग्रीमा छ भन्ने कुरा बुझ्नुहोस्. I have shown. Now, sin 54 degree, either you can write directly sin 54 degree, you can write down the value 0.809. See, there is minus 0.809. I have written 3, fix 3 upon sin 40. Sin 40 degree equal 0.64, nearly. Now, let me divide 0.809 divide by 0.642, 1.26. That is 1.26. Or nearly, you can also write 1.3 nearly, because these values are not 100% accurate. So you can write 1.26, or nearly you can write 1.3. This is nearly 1.3. You can write down यो 1.26 लेख्न पनि मिल्छ, accurate, or nearly 1.3 is also correct. Therefore, refractive index mu equal 1.3 nearly. See, first of all, you have to know the light is passing from denser to rarer medium. It is bent away, means denser to rarer. I, this is the angle of incidence, 90 minus 50, 40. angle of refraction 90 minus 36, 54. Then mu equals sine r by sine I. Tensor to sine 54 by sine 40 degree. Value sine 54 degree check, sine 40 degree check. It is very important even in optional math. Or let me check, see, by using the calculator directly. Sine 54 divided by sine 40 degree, 1.25. See, 1.258 something or 1.26. Directly you can write. So the refractive index of the medium is 1.3 nearly. ABC. Now D number, let me write another question. Another question is this one. See, from the diagram, this diagram shows that this is an incident ray. See the arrow, incident ray. The incident ray is bent towards the normal. Or the incident ray normal तिर आएको छ. So it is traveling from a rarer medium to a denser medium, because rarer to denser towards and denser to rarer away. You should know this technique. See, the ray is bent towards the normal. The ray is passing from a rarer medium to a denser medium. So what is the angle of incidence? What? And what is the angle of refraction? See here, angle of incidence equal what? This angle. And angle of refraction, is this the angle of refraction? No, it is not the angle of refraction. 90 degree minus 60 degree, 30 degree. This is the angle of refraction. This one, angle made by the refracted ray with the normal. 90 minus 30 degree angle of refraction. Refractive index mu equal 1.5 given. So what is the formula? We know refractive index equal sine I by sine R. Why? Not sine R by sine I, because the ray is passing from rarer to denser medium. Mu equals sine I upon sine R. Value of mu 1.5 given. Sine I, sine R is 30 degree, or sine I equal 1.5 into sine 30 degree, or sine I equal 1.5 into 1 by 2 means 0.75. Check with the